is 19 point what? 232. And set about 6. So our maximum shear or radius, right, of circle is equal to square root of 7.498 or minus 7.498 times 10 to the power 6 squared. Okay. I need more space. I do apologize. Right. Then we plus by 19.232 times 10 to the power 6 squared. Okay. So the radius of the circle 7.498 squared plus by 19.232 squared the whole thing is 20.64. Okay. So we know that that is our radius of the circle. And then next we can also calculate principal stresses. This is what we want to know. So it's stress 1 and 2. Later on I will tell you where is this on most circle. So it's equal to stress average plus minus by the radius of the circle. So this will be equal to minus 7.498 times 10 to the power 6. And we can have a plus minus of 20.64 times 10 to the power 6. Okay. So this will be equal to 20.64 plus by 7.498. So it's equal to minus 28.138 times 10 to the power 6 Pascal. And then the other value, minus 7.498 plus 20.64 is equal to 12.66 or 12.66 times 10 to the power 6 Pascal. Okay, so 7.498 minus 7.498 plus by 20.64. Oh, come on. 7.498 plus 20.64. I think I made it. It's 13.142. I do apologize. Positive 13.142 times 10 to the power 6. So minus 7.498 plus by 20.64, 13.142 minus, so 7.498 plus by 20.64 is equal to 28.138. Okay, so 28. So I knew it. My scale is not big enough. So I have another one. I need a minus 30 over here. And then normal stress, we are good. Okay, so for now, I can draw a straight line across. So from here, we can sketch our mole circle. We know the center of the circle, right? So it's 28. So you can use your mathematical set, which you're required to have in your exam. Okay, so 12.513. I'm just eyeballing this, okay? And then I will just bring this down. I'll just need to bring this up. The maximum is what? 20.64. So 20.64 is going up a bit. Okay, and then $20.64 here. 28 and 13.142. Okay. Somehow it don't look very circle to me. Yeah, it explain why, because I need to do this longer. better now. So the maximum 20.64. Maybe it's, let me see, 5, 10, 15, 20, 25, 30, 27. Maybe I need to squash this a bit. 27. Okay. That's why I don't like the scale. And then this is too high up. I think I need to squash this a bit. Okay. Anyway, it's a sketch. Okay. So this is our mole circle. So what we have calculated, right? What we have calculated. So this over here, I'm going to change color. I'm probably going to use red. Why not? So what we calculated earlier, sorry, wrong. Right. So this value that we calculated over here. Okay. So this is our tau max. And our tau max is equal to 20.64. Okay. And then we also have calculate our principal stresses. So over here, this is our stress 1. Over here, this is our, I'm not happy with the position of stress 2 because it is what? 13. Yeah, it's okay. So over here, this is our stress 2. Okay. Now we can flip it across over, does not matter. Okay. So if you look at stress 1 and stress 2, right, what will happen down here at stress 1 and stress 2, right, is what we have, the shear stress is equal to 0. And these are the two critical points. Why they are critical? Because these are our what? Principal stresses. Principal stresses is when the shear stress is equal to what? 0. Okay. So we know is minus 28.138 and the other one is 13.142. Now what we have just drawn is what we call 2D mole circle. Okay. To make it 3D, okay, so if you see over here, we have our point Y, right? And we have our point Z. Now, what we realize on point Y and point Z, right? The angle over here from point O is what? 180 degrees on mole circle. On the element from point Y to point Z is how many degrees? 90 degrees, right? So on the element is 90, okay? On mole circle is what? 180 degrees. So that's why it's twice. So anything on the element is half of that on mole circle, okay? Because if we look at element, element is the what? Is the real world. Element B over here, you can see in the real world, this is element B. Yes or no? Mole circle is just a tool to calculate the principal stresses. Okay, so to relate one to the other in terms of angles, on the element is what? 90 degrees. On mole circle is what? 180 degrees, as you can see from here. They're a good thing to remember. So if you were to ask me where is point X on mole circle, right? So if we look at point X, it has 0 normal stress, 0 shearing stress. This is where point X is. Okay, over here. So if we know that is point X, we can draw 2 more circles. Okay, so the first circle will be 2, 4, 5, 2.5. So one circle will be down here. Okay. So one circle will be here. Oh, too much. This circle is too big. Okay. So I do apologize. I did not label the circles first. Okay. So this big circle over here, right, belongs to the YZ plane. Later on, when I teach you 3D mold circle, I will teach you how to label. Okay, so now not yet. Okay, so now it's just let you see what 3D mold circle. This circle over here, right, belongs to the XY plane. Okay, and the last circle that I'm going to draw is so 2, 4, 6, 7. So the last circle that I'm going to draw again, this is a sketch. Okay, this belongs to the exact plane. So what you just seen, if it's just one circle, right? It's a 2D mold circle. The one that I just drawn that touch the YZ point, that's a 2D mold circle. If I add the other two circles, right, from point X to the edges of the big circle, this is what we call 3D mold circle. So to draw 3D mold circle, right, you have to do 2D first. Okay, knowing how to construct 2D first is more difficult than constructing 3D mold circle. So if we were to look on this element, right, just give me 2 more minutes, then we go for a break. We know that the in plane, we did this, okay? The in plane is your what? YZ plane. Okay. Your out of plane is both your what? Is both the XY plane and the other plane is YZ plane, no, XZ plane. Okay. So the YZ plane or XZ plane, the YZ plane, right, over here, this is what we call, this is our in plane. And the other two are out of plane. Okay, and this is also out of plane. And while doing 3D mold circle, I'll tell you why this is important. Okay. So for now, we go for 5 minutes break and we come back again.